Now, welcome to today's class. Today, I have an amazing lesson concerning probability and statistic 2. Specifically, I want to cover some three major areas. That is, how to get the median of a continuous random variable. Then, after that, we shall be looking at now how to get the upper and lower quartiles of the same continuous random variable. And lastly, we shall be able to look at how to get the median of a discrete random variable. Now, to begin, I want us to consider the above equation. You've been asked to find the median of the following PDF. The function is that is fx is equals to the provided function, that is 3x squared. We have a range provided there, 0 or elsewhere. Now, in case you've been provided with such a question, then you are asked to find the median of the above function. I want to show you the best and easy approach that you need to apply concerning the provided question. Now, let us look at the solution here. So that is the solution. That is the solution. Now, in case you are getting the median of a continuous random variable, the first thing you need to put in place is that you must ensure that you have an idea of integration. That is it. So what you need to be doing is just to come and write the provided formulas. Probably we have two formulas and I want to show you them. So the first formula is just put the integration sign, then at the upper limit write m. So m there is the median. So once we shall be in a position of getting m, already we shall be in a position of getting, that is the median. Then since m is at the upper limit, meaning the lower limit can go as far as negative infinity, because we can't estimate the exact value of the lower limit. So here we shall now come and say it is negative infinity. Then after that, just write the function there. The function is 3x squared. Just come here and write the function. And what was it? Fx. So since I am giving you the formula, instead of writing the function here, I'll write fx. So that is fx. And since we are integrating in terms of x, we shall now write that is dx. Now this is the first approach. Now the second approach should be the same as the first approach, and therefore we do equate the two. So the second approach here, you require you to just put the integration sign that way. Then now what will change is the upper as well as the lower limit only. The rest are just the same. So here, instead of us putting m as the upper limit, it should be now at the lower limit. So at the lower limit here, you are required to write m there. Then after that, since m is at the lower limit here, that one means that the upper limit can go as far as infinity. That is it, because we can't estimate the exact value of the upper limit. So you just come here and write that is infinity. Now after that, since it is a median, we do assume that it is a half. So we do just equate it to a half. And therefore, I told you that what will change is just the limit. Just write here fx, and since we were integrating in terms of dx, just put dx there. Then everything should give you that is a half. Now after that, you are required now to use whichever method you intend to use. You can use the first one, equate to a half, or the second one to equate to a half. Now in case we want to use that is the first one, so consider the first one, and the first one is that is integration of m negative infinity fx dx is equals to a half. I want to use this so that you will apply the same on the second approach. The answer will be the same. That is it. So now let us look at it now. Fx now is the function here, and it is 3x squared. So where fx is, we shall write that is 3x squared, then the rest are just the same. So you will put an integration sign that way, then m negative infinity there, then 3x squared dx, because we are integrating in terms of that is dx, is equals to that is a half. Now after that, your work is very simple, because you are just required to integrate 3x squared, and when you do so, what you are required to do, just add 1 to the power. So when you take 2 plus 1, probably 2 plus 1 is a 3, so you will have 3x cube, then you divide by the total power, which is 3, and therefore you will end up having something like 3x cube over 3. But remember to write the limits. The upper limit was m, while the lower limit was negative infinity. The whole is giving us a half. So that is that. Now after that, you can see something very unique here, whereby these 3 can cancel there, so that you remain with the rest, that is x cube, with the limits, the same limits, that is negative infinity there. The total is a half. Now after that, you are just required to substitute for the first case x with m. That is it. Then for the second case, you are supposed to substitute with the lower limit. So let us begin with the upper limit. So substitute x with m, it will be, that is m cube minus, now when you come to the lower limit here, it is a negative infinity. Now here, negative infinity, we do assume that it is a 0, because they are just the same. So instead of us using a negative infinity, it is better to use a 0, because they are just the same. So I'll just come here and substitute x with 0, and when you do such, it will be 0 cube there, and the total must be equals to a half. Now friends, when you look at here, you realize that 0 cube is just 0, and therefore you shall just remain with m cube. When you do such, you will just say m cube is equals to a half. Now after that, you can as well get m, because that's my main area of concern. So how can I get m, since it is m cube? By just getting the cube root, whereby the cube root here will go, because this power cancel it, and you will end up having m to be equals to, that is the cube root of 0.5, because a half is just the same as 0.5. Now after getting m, you shall just come here and say now that therefore median is equals to cube root of 0.5. Now you can leave your answer at this level here, or you can as well write a half instead of 0.5, or you can just dial cube root of 0.5 in your calculator, then you get the final answer. So all are just correct. Now that's the first case. I told you that I want us to look at median of a continuous random variable, a median as well of a discrete random variable, as well how to get the upper and lower quartiles. Now let us look at the second part. And now the second part here, I have now I have a question here that requires you to get the lower as well as the upper quartiles. Now look at the question now. It is all about upper quartile as well as the lower quartile of a continuous random variable. Now the question is, find the upper quartile and the lower quartile of the following PDF. Find the upper quartile and the lower quartile of the following PDF. So you have the function there, that is a 3x squared. Remember, we use the same function on getting, that is the median of the previous, that is a continuous random variable. So the function is just the same. Now let us look at the solution here. So I'll come here and write solution here, solution there. Now at solution there, consider this. You have upper quartile as well as the lower quartile. Now you can begin with any because they are independent. Getting the lower quartile is not affected by getting the upper quartile, so you can start with the upper quartile or the lower quartile, whichever. Now for now I want us to begin with the upper quartile. So upper quartile, remember upper quartile is framed as Q3, so I'll come here and write Q3, and Q3 is just the upper quartile. Now how can I get upper quartile? Now I want to give you the uniqueness concerning the three, that is upper quartile, lower quartile, as well as the median. Now the uniqueness is the formulas are just the same, but the difference is that you see the by the time you were under a median, we were using a half. So instead of us using a half at Q3, we shall just use 3/4 because it is an upper quarter. Now, by the time we shall be coming at lower quartile, we shall now use the 1/4. That is it. The rest are just the same. Remember, you saw me writing the formula as the integral, that is m being the upper limit, then negative infinity being the lower limit there. Then I wrote there f(x), that is the summation, the function I have here. Then we were integrating in terms of dx there. Then the result, now here Q3, I've told you that you just equate to 3/4. When we shall be coming to the lower quartile here, we shall substitute 3/4 with 1/4 only, and the rest just the same, meaning we are just required to use the same approach here on integrating, but we now use 3/4 only. Now let us now come here. It is now equals to m, that is a negative infinity there. Then what is the function of fx? It is now 3x squared dx. The rest is the same as 3/4. Now after that you can just come here and integrate that. Remember, you've seen us integrating it previously, looking at by the time we were looking at the median, whereby I told you that you just add 1 to the power here. When you add 1 to the power, that is 2 plus 1, which is 3, and that one shall be 3x cubed over 3, and you write the limits. I told you that is m negative infinity there, and the total must be equals to 3/4. Now after that you can see here also that 3 can cancel, so you come here, cancel 3. Now when you do such, you will end up by having x cubed with the same limits, m being the upper limit, negative infinity being the lower limit there, then equate to 3/4. Now after that here, I told you that you substitute mx with the m for the first case. When you do such, of course, you shall end up by having, that is m cube, so m cube minus, I told you earlier that this negative infinity can also be framed as a 0 because they are the same. So we shall just substitute x with a 0, so that is 0 cube being equals to 3/4 there. When you look at here, 0 cube is just a 0, so you will end up by having m cube being equals to 3/4. And of course I can get m now because I need to be getting cube root of the result, whereby I'll have m as the cube root of 3/4. Remember, 3/4 is the same as, that is a 0.75. You can as well write that, or I told you earlier that you can just dial everything in the calculator, that is a cube root of 3/4, then you just write the final answer. Now that is Q3. Now let us now look at the second case of Q1. And what is Q1? Q1 is now that is the lower quartile. Now let us look at Q1. And since I told you that the difference is very small, on just substituting 3/4 with a quarter only, but the rest are just the same. So the formula we shall be having now is that the integral of m negative infinity there, that is fx in terms of dx, is equals to now 1/4. Now after that you just write the function, and remember the function is just the same here. That's the function we are using, so that one is the same as that is m negative infinity there. Then it is 3x squared dx, and the rest is equals to 1 out of 4. Now after that, you are just required to integrate your function the same way we integrated here. And remember, by the time we integrated, we ended up having x cubed. So that's what I write. That is x cubed. Then you ensure that you write the limits. So when I write the limit, upper limit is m, lower limit is negative infinity, then is equals to 1 out of 4. Now friends, after that, you just need to substitute the same way we did there. The first case you substitute with m, the second case I'll substitute with negative infinity. Because I told you that negative infinity is just 0, then therefore when I'll be substituting it here, I'll end up having 0, the same way we ended up having 0 here. So there is no need of even substituting it since you've understood. So I'll just need to substitute with that is m. So when you substitute x with m, you will end up having m cubed being equals to 1 out of 4. Now how can I get m? I just need to get the cube root. I just need to get the cube root, whereby my m shall now come to an end by getting that is the cube root of 1 out of 4. When you do such, you will have gotten that is the lower quartile, and that one shall be your final answer. Since you've gotten the upper quartile as a cube root of 3 over 4, the lower quartile as that is a cube root of 1 over 4, as well, you saw as previously we gotten the mean as a cube root of a half. You will have just gotten both upper quartile, lower quartile, as well as that is the mean of a continuous random variable. Now lastly, I want us to look at something now concerning discrete random variable. Now consider that question there. You've been told that the median, that is the median of a discrete random variable, and the question is there, that is find the median of the following. Remember, you've been now given the variable with the respective probability. Yes, so you can study it when the variable x, when it is 0, you can see that the probability is 1 over 8. As well, when it is 1, it is 3 over 8, and the line just goes that way. So the question is, how can I get the median of that PMF? Remember, that is a PMF. So let us write the solution there so that we can see how we can solve that. Now, under solution here, it is now different with the way we solve the continuous random variable. Now, in this case here, you shall just come here and just find the summation of m. You just write m at the upper there, then the lower here you just say x turning to x1. After that, you are just required now to write x, then you write the probability, respective probability when capital X is turning to small x, that way. Now after that, remember, by the time we were getting the median, I told you that we consider a half. So in this case here, when m is at the upper side here, we just assume that the function, the whole of this is greater or equals to a half. That is it. Now in the other hand, you may intend to put this m at the lower side here, and when you put the m at the lower side here, that one means that the whole shall be less or equals to a half. So that's the only difference. Now for now, I want us to consider this formula here I've presented to you, so that we can see how now we can get the median of the provided that is a discrete random variable. Now what you need to be doing is this: you are just required to count here. Under discrete here, we just count. There is no need of integrating or differentiating, whichever. What you need to be doing, you just count the probabilities up to where you will meet either a half or any number above a half, but it is for the first time. That is it. So you shall just come at the probabilities here. You begin here. 1 over 8. Remember, when x is 0, it is 1 over 8. So I'll just consider 1 over 8 if it is more than a half, or it is a half. Now when you consider 1 over 8 and a half, you realize that a half is greater than 1 over 8, and therefore it doesn't satisfy what I have here. Remember, it is greater or equals to a half, meaning it can be a half or above a half, but not below a half. And therefore that one will force me to write here a half, that is 1 over 8, that is 1 over 8, which is this. And since it did not satisfy my function here, it will force me to move to the next. So my next is 3 over 8. Now by the time you are moving to the next here, you are required to add. Don't just come at 3 over 8 here and consider it alone. You are supposed to add 1 over 8 plus 3 out of 8. Then you just have a look at the overview where you shall be concerned of whether it is more than a half or it is a half. If it is below a half, that one will mean that you need to be adding the next. But if it did satisfy this, you just need to stop at that end. And now let us see the result here. Probably when you take 1 over 8 plus 3 over 8, it will be, that is 4 out of 8, of which when you simplify, it will be a half. Now consider that. Remember, we wanted either a half here or any value that is above a half, but it is for the first time. Now a half is already gotten here, and it is gotten when x is 1. And therefore, since we've gotten a half when x is 1, that one means my value of m, which is here, shall be 1. That is it. My value of m shall be 1. So what you need to be doing, just come here and write m being equals to 1, because you realize that it is up to 3 over 8, the first 3 over 8 that satisfy the provided equation here. So that's where I'll reach. So m therefore is equals to 1 there. Now after that, you just come and say now therefore that is median is equals to now 1, and you shall have just arrived to the final answer, and you shall have concluded. So those are the techniques that normally guide us on getting the median of the three, that is using discrete random variable, or as well as using that is a continuous random variable, and finally getting the upper as well as the lower quartile. Now I think having illustrated the all that I presented to you today, you will be in a position of understanding the techniques and the trends and even the key areas that we normally look at concerning the equations under that particular area. Otherwise, don't forget to subscribe so that you need to be notified or concerning there is any event that I present to you there. Share the provided videos to as many of your friends as possible so that they can also benefit. Otherwise, let me meet you in the next class.